Hello student, let us see whenever the sharing of charges takes place between the two plates of the capacitor, there is always some heat energy developed in the connecting wire. Now we'll observe whenever a capacitor is charged with the battery, then battery supplies some charge to the positive plate of the capacitor, and in steady state, within short time, very short time, the one plate of the capacitor is charged and another plate is negatively charged. Now once the capacitor is charged by the battery, we'll observe the energy supplied by the battery is converted in the form of electrostatic potential energy between the two parallel plates of the capacitor and stored between the two plates of the capacitor, and part of the energy supplied by the battery is converted in the form of heat, because the battery has to supply the charge and then it flows through the connecting wire, and while the charges are flowing through the connecting wire, we'll always observe the kinetic energy of the charged particle is converted into the heat energy, or heat is developed in the connecting wire. So we want to find out what is the amount of heat energy developed in the connecting wire in different situations where the two plates of the capacitor is connected to the battery. Now we'll take broadly we can classify this the heat energy we can find out in two different situations. First situation will take when the two plates of the capacitor is having equal and opposite charges, and in second example we'll consider when the two plates of the capacitor is having two different charges, and once they are connected to the battery, how the sharing of charge takes place and what amount of heat energy is developed in the connecting wire. So first example, we'll take this one. A capacitor is initially charged with 50 microcoulomb. The positive plate is having 50 microcoulomb, negative is minus 50. So charge of the capacitor is 50 microcoulomb initially. So I can say the initial charge, I can say the capacitor is having 50 microcoulomb, and I can also find out the initial potential difference between the two plates can be written as Qi by C, and this Qi is nothing but 50 by C is 10 microfarad. So I can say this is 5 volt, right? Now you will observe here, once these two plates of the capacitor is connected to the two terminals of the battery and a switch is connected. Now when the switch is closed, when S is closed, now the charge on the plate of the capacitor will change. I can find out the final charge on the plate of the capacitor as C times V of battery, and C is nothing but 10 micro farad is the capacitance, and potentiality of battery is 10 volt. I can write, so this is now 100 microcoulomb. Is it clear? Now what amount of charge has flown? What amount of charge has flown from the battery? What amount of charge has been supplied by the battery? I can find out as QF minus QI. QF is 100 and QI is 50. So I can say 50 microcoulomb is the charge supplied by the battery. Now I can say while the battery is supplying the charge to the capacitor, the battery does some work. I can say the work done by the battery or work of the battery can be written as delta Q times the potential difference is 10 volt. So 10, I can say, first you write down V is the potential and V of the battery, and delta Q is 50, battery potential difference is 10. So 500 microjoule of work is done, and this much of energy is supplied to the circuit, to a system, entire system. Now I can say the initial energy which has been stored between the two plates of the capacitor half times, I will take Q initial and V initial, right? Now what is Q initial? Q initial is nothing but 50, and V initial, how can we find out? 5. So this comes as 125 microjoule. Is it clear? Now I can find out the final electrostatic potential energy between two parallel plates of the capacitor. I have QF and V. VF is nothing but V battery, and half QF is nothing but it is 50, and the potential, the final potential battery, that is 10. So this is 250 microjoule. Is it clear? Half QF is QF is 100. QF is 100. 100, and I can say 500. 500 microjoule. Is it clear? The final. So what is the increase in, while the charge is supplied to the capacitor charges increases, and electrostatic potential energy between the two plates also increases. So what is increase? I can say E final of the capacitor minus E initial of the capacitor, that is nothing. Final is 500 and this is 125. So this is 375 microjoule. So I can say the amount of heat energy which has been developed, the work done by battery or energy supplied by the battery, part of this work is used, part of this energy supplied by the battery is used in increasing the potential energy of the capacitor, and part is used in heating the wire. So I can say WP is 500, I can say, and this is 375. So I can say 125 microjoule of heat is developed in the connecting wire, right? Now in second example, what we have done actually, in second example, we have changed the polarity of the battery. Now the positive plate is connected to the negative plate of the capacitor, and negative plate is connected to the positive plate. Now in this situation, what is final charge when switch is closed, or when AC is closed, the final charge can be written as C times V of battery, and 10 into 10 100 microcoulomb. Is it 100 microcoulomb? Now I can say here now what is the charge supplied, that initial, now the capacitor is having, this will plate, simply the example will be like this will be having plus 100 microcoulomb, and this will be having minus 100. Now the positive plate, which was initially having 50 microcoulomb, has now minus 100 micro. So what is Q final? I can say initial delta Q can be written as Q initial minus Q final. So Q initial was 50 and minus of minus 100. So 100 microcoulomb of charge has flown through the battery. Is it clear? Now first this positive plate neutralizes this minus 50 microcoulomb, and then it supplies the charge to charging this one, that is 100 microcoulomb. So the total amount of charge which has flown is minus 100. You can take 100, 50 minus 100 minus 100, that is 150. And now work done by battery is now written as, work done by battery can be written as delta Q into V, that is 150 into 10, and that is nothing but 1500 microjoule. Is the energy supplied now by the battery. Now the initial energy stored in the capacitor was EIC, was nothing but half times Q was 50, initially V 5, so the half, C was 10, Q is 50 and C is 10, so 250 microjoule, I can say. Half Q was 50, so initial was 50, then potential in half Q V was 5 actually, so this value is now 125, this value is 125 microjoule. Is it clear? 50, 25 into 5. Now the final energy stored in the half. Now final charge is 100 and potential is 10, so I can say 500 microjoule, right? Now I can find out what is increase now. The increase is nothing but 500 minus 125, that is 375 microjoule is increased. So I can once again find out the heat energy, the energy supplied by the battery or work done by the battery in charging the plate of the capacitor minus the increase in energy of the capacitor. I can say it is equal to 1500 minus 125. I can say, 375. 375, I can say it is 1125 microjoule of heat is developed in heating the wire. Now here it is more heat is energy developed. Why? Because the minus 5 to 50 microcoulomb is first neutralized by the battery, and then additional 100 microcoulomb of charge is supplied. So total charge is supplied is 150 microcoulomb. That is why in this case the charge supplied was only, I think it was 50 microcoulomb. So more work is whatever battery, the more work is done by the battery in the second case than in the first case. In first case it was only 500 microjoule, and in second case energy supplied was 1500 microjoule. So that is why heat energy developed there is more, 1125 microjoule. Now let us take the third example, when the two plates of the capacitor is not having equal and opposite charges, but they are having unequal charges, and now they are connected to the battery. Then what happens? How to find out energy dissipated in the connecting wire. Now the third example we'll take now. Let us take the third example. The third example I'll take as third example. Now the two parallel plate of the capacitor is not having equal amount of charge. Now the charges on the two plates are 20 microcoulomb and 40 microcoulomb. Now this is having 20 microcoulomb of charge, and this is having 40 microcoulomb, and the capacitance is, let us take 5 microfarad. This is 5 microfarad. And when it is connected to 6 volt, now this is the situation. Now initially, first let us see the distribution of charges. How to find out distribution of charges here? I can say the capacitor is now the outer two plates, outer side of the two plates of the capacitor will take the half of the total charge. So 20 plus 40, 60 divided by 2. Q1 plus Q2 by 2 on the other two plates. So I can say plus 30 microcoulomb, and this will also have plus 30 microcoulomb, and since it is having 20 microcoulomb as a charge, so 30, so this plate, this side will have 10 microcoulomb, and this will have plus 10 microcoulomb. Now this is the initial situation. The C is 5 microfarad. Right. Now I can say the initial charge of the capacitor is only 10 microcoulomb. Please mind it. This is the initial charge, and I can say the initial voltage is now QCV 5 times 10 divided by 5, 2 volt, and initial energy stored in the capacitor can be half QI VI. Again, half QI is 10 and V is 2, so 10 microjoule. Is it clear? 10 microjoule. Now this plate is, two plates are connected to a battery having 6 volt as battery potential difference. Now this is 6 volt. Now once it is connected to 6 volt, these charges will not remain like this. Now it will redistribute, the redistribution of charges will take place. Now I can find out the final charge now is C times B, now 5, and B is how much? 6. So I can say 30 microcoulomb. So you will observe now the two plates of the capacitor, since this is positive, so this side it will be 30 microcoulomb and this will have minus 30 microcoulomb. Now since the initial charge was 60 microcoulomb, so you will observe this is plus 30, then outer this will be having 30 microcoulomb and this will have 30 microcoulomb. Is it clear? And it is connected to battery. So now the final charge of the capacitor, we know it is 30 microcoulomb. Right. Now what amount of energy is stored in the final stage? I can say the final energy stored in the capacitor can be written half times QF into V, that is 6 volt. So half QF is 30 and V is 6. So 90 microjoule. 90 microjoule is the final potential energy stored. Now the increase in potential energy is how much? I can say the increase is now 90 is final minus initial energy was 10, so 80 microjoule. 80 microjoule. Is it clear? Now, since it is supplied, what amount of charge has flown? Now, initially the positive plate was having minus 10 microcoulomb and finally the charge is 30 microcoulomb. So, how much charge is supplied by the battery delta Q can be written as QF minus QI, and QF is nothing but it was 30 microcoulomb and minus of 10 microcoulomb was initially. So this becomes 40 microcoulomb of charge is being supplied. So work done by the battery can be written as delta Q times potential of the battery, that is 40 times battery potential 6. So I can say 240 microjoule of energy is being supplied. Right. Now I can say now the heat energy developed is nothing but energy supplied by the battery or work done by the battery in carrying the charge minus the increase in electrostatic potential energy between the two parallel plates of the capacitor. So I can say it is 240 minus of 80. So I can say 160 microjoule of heat energy is developed in the connecting wire. Is it clear? This example, very simple, how to find out, right? I can say the second example, let us take one more example. One more example we'll take when the two plates is having, let us see, 100 microcoulomb and 300 microcoulomb charges. Let us see how to find out in that situation. When it is fourth example, we'll take the fourth example and then we'll see the situation how to find out in that case. Let us take the fourth example, how to find out the in fourth example, we'll take the two plates. This is having 100 microcoulomb, right? And second plate is having 300 microcoulomb. 300 microcoulomb, and let us take the capacitance is 20 microfarad. Now first, how to find out distribution? So you do add these two charges, 300 plus 100, 400, divide in two parts. So on outer plate, on outer side, this will be 200 microcoulomb and plus 200 microcoulomb. Very simple. 300 plus 100 is 400. Divide it in two parts. On outer side 200. Now since this is having net charge of this plate is 100 microcoulomb, this 200 on this side. So on this side it will be minus 100 microcoulomb and this will have plus 100 microcoulomb. So I can say the initial charge of the capacitor is only 100 microcoulomb. I can say initial energy stored is nothing but half Qi, and V you can write Vi can be written as Qi by C. Qi is 100 only and C is how much? 20. So 5 volt. 5 volt is initial potential difference. Is it? Now this will be at higher potential, this will be at lower potential. Why? Because this is having plus 100 micron. So Qi Vi initial is half. Qi is 100 and Vi is 5. So I can say 250 microjoule. 250 microjoule of heat, energy is stored. Now once these two plates are connected to, suppose these two plates are connected to a battery having 20 volt, this is having 20 volt, right? Minus, plus, now this is 20 volt. And now 20 volt our final charge when we find out C times V. Now C was 20. So 20 into 20, it will be 400 microcoulomb is final charge. So I can say this will have 400 microcoulomb and this side will have minus 400 microcoulomb. And since initial charge was 300 plus 400, so this will have 200 microcoulomb and this will have 200 microcoulomb. Is it? No. No. This will have 400 micro minus 400. Total charge was 400 microcoulomb. So I can say this will have no charge here. Plus 200 microcoulomb. And this will have plus 200 microcoulomb of charge. Then minus 200 will be this one, no. Yeah, see, this is charge of Is it clear? This will have cancel, these two gets cancelled, 200 will become 400 microcoulomb. So this will be the distribution of charge. Now I can find out the charge flown is nothing but QF, since this is my QF minus Qi. Now this is 400 and minus of 100. So I can say it is 500, right? 500 microcoulomb. Now kind of work done by battery can be written as delta Q times V battery, and this is 500 and V battery is 20. So I can say 1000 microjoule. Is it clear? Now what is final energy stored in the capacitor? Final of the capacitor half Q 400 and 20. So I can say this is 10. This will be 400 microcoulomb. 5 चौका 2000. हजार 2000 10 4000 4000 half into